Direct variation is where we kind of just get tiptoe into the waters of graphing lines and finding the slope and writing those equations. And as you'll see, direct variation is a simple form of a linear equation that all of these go through the origin, and you'll be picking up on characteristics like if the slope is a larger number, then it's going to be steeper. Is it positive? Is it negative? And that type thing. So our target today is that we will write and we will graph these equations of direct variation. If you define direct variation, it is a relationship, which we know all about that from our functions chapter, that can be represented by a function in the form of y equals kx, where k does not equal 0. That k is some sort of number. It's -1. It's 3/2. The k is the number, and the x and the y, they just stay there. K has a special name. It is called the constant of variation. If you'll think back to our last lesson on rate of change, we had that one slide where we talked about is the rate of change constant. If a line is constant, then it doesn't have any bends or any curves in it, and so it's that constant of variation, that constant of change. And this is what we call the slope, and that slope meaning that it doesn't change. The x and the y, these are coordinates of the function, and these numbers can change. You could substitute those in. So the slope is whatever number you are that you're multiplying by the x value that gives you a certain y value. So how do you find k, that constant of variation? We know that a direct variation equation is y equals kx. So if I'm wanting to find k, that's like where you solve for k. Think back to literal equations. You're wanting to isolate k. So we ask ourselves, what's happening to k? It's being multiplied by x. So I undo multiplying by x on each side. You see that being done there. And so literal equations are our favorite lesson. We were all awesome at it. And so whenever you clean that up, you have y over x equals k. So if you're wanting to find that constant of variation, all you have to do is to divide your y value by your x value, and then that's going to give you k, that constant of variation. So if you're wanting to identify a direct variation, are you wanting to see if that equation can be a direct variation? So how you do that is you ask yourself, can you write that equation in the form of y equals kx? So let's test this one out. If I'm wanting to isolate y, so in order to isolate y, I'm going to have to move this 4x. So I move it by subtracting it on both sides. So when I do that, I have 5y equals -4x. Still wanting to isolate y, so I undo multiplying by 5 by dividing by 5 on both sides. That cancels. So to clean this up, I have y equals -4/5x. It does look like this. My k value would be -4/5. The x is out there on its own. So yes, this first one is direct variation. Now let's take a look at the second one. Wanting to isolate y, so all I have to do is undo multiplying by 2 by dividing by 2 on both sides. So it cancels here, and I need to clean up the other side. It's like I'm distributing that dividing by 2. So I have 5/2x plus 1/2. This is a linear equation, but it's not a direct variation because I have this plus 1/2. That plus 1/2 right there is the kicker. That's what makes it not direct variation. So you want to see, is there some sort of like constant number that is not attached to a variable? That plus 1 right there would have shown us initially that it is not direct variation. So if you're wanting to write a direct variation equation, keep these two things in mind. Direct variation looks like y equals kx, and you find k by dividing the y value by the x value, stacking them on top of each other. Remember changing y over changing x? That's your k, because k is really the slope of the line. So here's your setting up here. Suppose y varies directly, which means it's not affected by a constant. Remember that plus 1 over here? That makes where it's not varying directly. It's being affected by something else, by that constant value. So suppose y varies directly with x, y equals 10, and x equals negative 2. The first thing is, what direct variation equation relates x and y? So I need to set it up into this form. I need to figure out what k is. And so to find k, I'm going to divide the y value by the x value. So first step is to find k. K is equal to the y value, 10, over the x value, negative 2. Now I can clean that up. 10 divided by negative 2 is negative 5. So that's my k value, negative 5. Then I just need to build the equation. I need to plug that into there. So my equation will be y equals negative 5x. There's my equation. So that takes care of this first question. What's the direct variation equation? The second part is, what is the value for y when x is negative 15? So if I were to put negative 15 into that equation, y equals negative 5 times negative 15. So y would equal, negative times negative is positive, 5 times 15 is 75. So there's the second part of the question. For graphing a direct variation, here is my equation, y equals negative 1/2 x. Now keep this in mind, the graph of a direct variation, this line is direct variation because it passes through the origin. So here's an example of another one. This is the graph for y equals 2x. It's always going to pass through the origin. That is huge. Passes through the origin. That's because it does not have that constant, which is going to make the graph shift up or shift down. And remember that the k value is really the slope. Our slope here is negative, so that means our line is going to be decreasing. It's going to be going down. So I know that goes through the origin there. The 1 is like my y value. The 2 is like the x, or I'm sorry, I should have said the change in my y values. So I'm going to go down 1 over 2. Whoopsie daisy. There we go. Down 1 over 2. Down 1 over 2. Down 1 over 2. I could go the other way. Up 1, left 2. Up 1, left 2. And so forth. And then I can get me a line here. Let's make it not so big. Put some arrows on the ends of it, because this could extend infinitely in the other direction. And I'm going to connect those dots, extending it out. There we go. And there is our graph of y equals negative 1/2 x. So this kind of sums it up for us. The graph of a direct variation equation is y equals kx. It has these properties. The line passes through 0, 0, that's the origin, and the slope of the line is k. If k is larger than 0, meaning it's positive, it's going to point up. If k is less than 0, the slope is negative, it's going to point down.